Cell and Genetic Biology 230. This is Dr. Chastity Bradford, and we are continuing to dive into Chapter 3, and we are almost at the end. We are at Chapter 3.2, and this concept reviews water and its ability to be a very versatile solvent. Okay? Terms again. We have to know our terms. What is a solvent? What's a solute? What is a solution? Water is a versatile solvent because it is extremely polar, and we've reviewed that ad nauseum. And it can form aqueous solutions. So, for example, we have 3 scales here, and here I am highlighting the solvent. So the solvent is the dissolving agent. The solvent is the dissolving agent. Okay? And we're saying water is a very versatile dissolving agent or solvent. Okay? And what you have here in the on the second scale is our solute, or a solute, and this is the substance that will be dissolved in the solvent. And then in the end you have a solution that you have prepared. The solution is the liquid that is a homogeneous mixture of 2 or more substances. So what we notice here is that we have our solvent, we put our solute into our solvent, creating a solution, and the mass tells us that everything is still there. So from 100 grams plus 10 grams, we mix them both together, and we have 110 grams. Now, water can dissolve ionic compounds very well. It's an excellent solvent for polar compounds, polar substances as well, but it's a poor solvent for nonpolar substances. So let's look at how water actually dissolves materials. What you see here is, of course, our water molecules that we always see, with our oxygen atom here and then our 2 hydrogen atoms in white. And you see sodium and chloride anions, sodium cations and chloride anions, and of course with sodium chloride, that is just table salt. How do we actually dissolve salt in water? How does this actually occur? I want you to get to the place where you're always asking, how is this happening? You know, really diving in. How is this happening? When you have a sore throat, they tell you to rinse your throat, gargle with salt water, and it really does work. Warm salt water. How, when you are putting the salt into the water, how is it actually dissolving the salt? This is how it actually happens. You notice here that your oxygen, your negative oxygen regions of these water molecules, they're attracted, of course, to the cations, to the sodium cations. And then the positive regions, the positive hydrogen regions of the water molecules, they seem to be attracted to the anions. It makes sense, right? Opposites attract. And what happens? They form these hydration shells. These are called hydration shells. They're formed around the material that they want to dissolve. What they end up doing is overcoming the charge or the interactions that they have with the sodium and the chloride. They overcome these electrostatic interactions, okay? And they begin to dissolve them. They interact with the ionic compounds, called the solutes, and they dissolve these compounds. And now let's review hydrophilic versus hydrophobic. You'll see this all the time throughout this course, and then you'll also see it as you continue and matriculate throughout your time at Tuskegee University. A hydrophilic substance is one that has a high affinity for water, so water loving. And then a hydrophobic substance, on the other hand, is one that does not have an affinity for water. And what we see here, and we often talk about the fact that oil and water do not mix. They do not mix. And so You see here, when we have the big oil spill, how are they able to clean this up? They're still trying to figure out how to get the oil out of the ocean. And I want you to just look at that and let's dialogue about it on Blackboard, the Blackboard forum. Talk to me about how they have attempted to clean up this oil spill. How do they attempt to remove this hydrophobic substance from water? Because we know the two do not mix. So as we mentioned, water is a very versatile solvent. It can dissolve just about anything. And also most biochemical reactions occur in water. So it truly is a versatile solvent, and it truly is something that we need to live. So one of the things that's going to be important for you to understand how to do is how to calculate the concentration of solutes in an aqueous solution, because scientists and students were always calculating things within the lab, calculating concentrations. And so I want you to be able to know how to do this when someone asks you, okay, I need you to make 1 molar solution of sucrose. You should be able to do that. And this is how you would go about doing it. What is sucrose? It really just is table sugar. And you have to know what the molecular mass of sucrose is in order to make that 1 molar solution of sucrose. And molecular mass just simply is defined as the sum of all masses of all atoms in a molecule. Okay? And so for table sugar or sucrose, there are 12 carbon atoms, 22 hydrogen atoms, 11 oxygen atoms, and thus there are 342 Daltons. So you have to know the mass of each atom. So the mass of carbon you must know, the mass of hydrogen, and the mass of oxygen in order to come up with 342 Daltons. And you will be asked to do this. Okay? Now let's move on to defining what a mole is. A mole represents an exact number of molecules of a substance in a given mass. So it's just like when anybody says a dozen, they're talking about 12. Whenever anybody says half a dozen, they're talking about 6. So it's a fixed number. So whenever someone's asking about a mole, they're saying 6.02 times 10 to the 23 Daltons in 1 gram. So they're actually talking about Avogadro's number. 1 mole of sucrose contains 6.02 times 10 to the 23 molecules. So if I ask you how many molecules are in a mole of sucrose, you should be able to tell me 6.02 times 10 to the 23 molecules, right? Okay. And so, therefore, because of this relationship between the Daltons and the grams, so because there's 6.02 times 10 to the 23 Daltons in 1 gram, then I can then say that in a mole of sucrose, there are 342 grams. So, I say, okay, I need you to make me 1 molar solution of sucrose. You know the molecular mass, so then you're able to come up with how many grams you need to weigh out on the scale for a mole. And now you need to figure out the other component of molarity, which is the liter. So molarity equals mole of solute divided by liter of solution. So you know there are 342 grams in a mole, but you're going to dissolve this in a liter of solution. Now, what you will not do is take 1 liter, measure it up in your graduated cylinder, and then pour 342 grams into that. That's not how we do it. You will measure out 342 grams of sucrose, and then you will take a beaker and you'll add about 500 milliliters of whatever solution I ask you to dissolve it in. So say it's water, okay? You'll have 500 milliliters of water. You'll add your 342 grams of solution in 342 grams of solute. How I just wanted to see if you are awake. 342 grams of solute into that solvent to create our solution, our 1 molar solution. But we only have, maybe a little more than 500 now because of the fact that we've added 342 grams. So let's say now it's up to about, say, 700 milliliters. So now we're going to add 300 more milliliters of water to bring our volume up to 1 liter. That's how you will prepare 1 molar solution of sucrose. Now you're ready to join the lab. Almost ready.